Hello everyone. The first lockdown happened in March 2020, and since then, it has been very difficult for the students as well as the teachers to maintain and go on with the syllabus. But then, the theory classes was more or less easily managed using online classes, but for practical, it became really difficult. Recently, when I was taking practical classes for my students, I did realize that it took a lot of effort to bring the student back into this offline mode, and there were cases where many students were really not aware of how the practical classes are being done, how the examination will be, and so on. So I thought of making up this video where I'd like to tell you how exactly the practical sessions are conducted in general. It's a tragedy that in 11, 12, though there are practicals, but there are students who have never appeared for those practicals offline, or even if they appeared, that was more or less compromised in such a way so that it can be a bit easier for the students. But in reality, the practicals are very important and it cannot happen if you are not in the lab. So in general, when you are doing a practical for a particular semester or year, every week you are supposed to do at least one practical, and then you are supposed to prepare that practical in a record book and submit it the next week. That's how the procedure is in the institutes, and that's very important that we follow that. So what happens is you do a practical, you go back your home, and when you come for the next practical, before you start your next practical, you should write down your aim, apparatus, theory, calculation, observation, whatever readings you have taken, and so on. If there is any graph, you should make it on a graph paper and not on a normal page. And the tabulations and all should be written. If there is any kind of circuit diagram, that should be included with the theory. But please make sure that when you do such things, theory and circuit diagram and apparatus and aim and everything, okay, it's as per the manual will be provided to you. You can write it according to the manual. Many a time it does happen that the theory is a bit too long. When you're writing it down and noting it down from the manual, you should write down the entire theory. How you're supposed to write it for the exam, I'll come to that later. And observations and all, whatever reading you write down, you should write it with a pen. Now my student do ask me, so I've written it with a pencil, what's the harm, right? But then, observations are something which you have come in the lab and done it on your own, and you have taken up that reading. And there should be no, chance of modifying that readings. Okay? That is something which you have done in the lab, and it should not be modified later. And that reason is enough to understand that you should write it with a pen and not with a pencil, so that it's not modified after it is signed. Okay. Secondly, when we actually write down the final answer, you should also look into the error. So if there are any kind of calculations, for example, you're finding out the frequency of the AC mains, it's one important lab practical in undergrad exams or undergrad labs. So what happens is you are basically finding out the frequency experimentally, and then you can take the theoretical value and find out the error and include that in your result. That's very important. And finally, precaution. So when you do the experiment, certain things should not be done so that the experiment turns out correctly. Those should also be written. Now this should be done, and if there are, let's say, 8 practicals, 9 practicals, all 8 or 9 practicals should be done before the exam. But I know that there are cases where the practicals classes were started late, okay, and before that everything was online. So there will be a bit difficulty in a smooth transition from online to offline. So that's the reason that many a student would not be doing those all practicals which are listed in the manual. So what you can do is maximum number of practicals should be done, and for exam purpose you should actually study all those practicals. You study the aim apparatus obviously, and then you study the theory. And see, in theory it does happen that there are a lot of theory in some of the experiments. It's too long and it's a bit difficult to remember everything. What I suggest personally is that it's important that you write down the main points. The main points should actually include what's the working formula, and you should explain the working formula. That's very important. If there is any kind of important points that you want to note down, for example, you are doing an experiment on p-n junction, at least in the theory you should mention what is a p-n junction, and you are doing a connection which is forward bias and reverse bias, so you should mention what is forward bias and reverse bias, okay. And then you are drawing a graph which we basically call as the IV characteristics graph, right? So you should mention about the graph also, that what you are supposed to, what are you expecting in forward bias and what are you expecting in the reverse bias. For forward bias, the voltage will be small, and you are going to get a current which will be in milliamps. For reverse bias, the voltage will be high, but then the current will be in microamps. For silicon in reverse bias, you might be getting no current at all, right? So depletion layer and all comes into an effect. So these things should be explained. It's not that you should write down the exact thing whatever is written in the manual, but it's important that you write down the main points. So these are some of the things that should be taken care of while writing down the theory. For observations and calculations, you should remember the table for exam purpose. And when you come in the lab and do your experiment, you should actually write down the readings when you're performing the experiment. Usually the viva is conducted when you are doing the experiment, so that the external knows that how you're doing the experiment, whether you know about it or not. Okay, so don't by heart the readings. That's very important, because some students have this notion that if I by heart the readings, I'm going to get the exact result and I'm going to get better marks for that. That is something which is absolutely wrong, because for accuracy the marks will be around 2 to 3. So even if your answer is not very accurate, for example, you are finding out acceleration due to gravity by Kato's pendulum, you know that the value is 9.8 meter per second square, and you're doing your calculations, and in the lab when you're doing your practicals, maybe you got around 8.5, 8.6, very close to the actual value. But when you're doing it in the exam, you might be getting a value of around 7, 6.5, maybe. It's fine, because it's not accurate. Okay, it's not supposed to be accurate because you're doing it on your own. Okay, this instrument also has some kind of error, so it's totally fine. You don't need an accurate value. So manipulation is something which should definitely be avoided. If you do that, usually you will end up in trouble. So that's how you actually go for writing down the practicals, and then you should do your calculations and all. So usually you are very well versed with the experiment. Usually you can finish a practical exam within an hour. So that's important. And also take care that when you actually prepare for your viva, for your external exam, it's usually the questions which are based on the practical that you would be doing. So how it's done: initially when you come in the lab, you are supposed to submit your practical copy, and then suppose there are 7 experiments that are being done in the lab. The slips will be prepared, 7 experiments, and they will be kept upside down on the table, and you will be asked to choose one experiment. Now you pick up one experiment, you get that experiment, and that is the experiment that will be allotted to you for that day. Now suppose you have not done the experiment, these might be the situations nowadays, right? So that will be actually dependent on the internal and the external examiners, whether they really want to change it or not. If they change it, they will keep the experiment which you have done maybe, and then you can pick up the cheat, and then whatever experiment you get, you're supposed to do that. Okay, so that can be adjusted. Obviously we need to adjust that. That's very important, because if you have not done an experiment, you cannot do it during practical classes also. So with that, I would like to wish all of you good luck for your upcoming exams, because nowadays everything has transformed from online to offline. But I'm sure that you'll be able to do well. It all depends on how sincere you are and how much effort you put in. For practicals, keep the basics very simple. Try to remember how you've done your experiment and do it properly, because most of the mark is basically based on how you're performing it in the lab and how you're doing your calculations and writing down the observation table. The aim apparatus in theory also has got some good marks, so please make sure you do that properly. The minimum marks will be in the lab record. There will be some marks, but definitely it's not too much. In accuracy, okay, it's there, but then again I told you it may be around 2 to 3 or 4 marks max. Okay, and then finally viva. So viva is important. Sometimes you do a very good viva, even if you have not done the practical that well, that actually impacts your marks. So that's important. So for viva, you should prepare it in a very simple way. Whatever experiment you are doing, you should know the basics. Let me tell you some important experiments. For example, you're doing experiment on Kato's pendulum. The Kato's pendulum is a compound pendulum, so you should know what's the difference between a compound pendulum and a simple pendulum. Secondly, you should know what is acceleration due to gravity's definition. You should know what we mean by center of mass, okay, time period, frequency. These are the basic definitions that is very important. And when you come for the working formula, you should know each and every term in the working formula. If you don't know the derivation or how the formula is derived, it's still fine. But then the terms in the working formula is important. In a gist, I can say that if you're writing down something in the theory part, you should know what are the terms that are there in the theory part. Each and every term should be easy to explain. Okay, so that's important. That's what the external and the internals are looking for. And if you follow that instructions, you should be able to do well in your practicals. And that's not the case only for my subject. I'm teaching physics. It may be it's applicable for chemistry, it's applicable for computers and so on. Okay, so mechanical, civil, whatever experiment you usually do in a lab, usually these are the basic thumb rules that you should always follow. So all the best, and stay safe.